To show you how to draw a table, we'll be using the following experiment, where we want to know how the length of a metal bar will change at different temperatures. In this experiment, we have a metal bar. We measure its length in millimeters at 10 degrees C using a ruler. We heat the rod, which causes the metal to expand, and as a result, the length of the rod increases. We measure the length of the rod at the new temperature, and the difference between this length and the length at 10 degrees C is recorded. By now, it should be obvious that we have some variables. The independent variable is the temperature of the metal rod, and the dependent variable is the expansion that's happened, that is the difference in the length between the new temperature and the temperature at 10 degrees C. We then need to draw a table, a results table, and it's important to plan this. First off, we need to make sure we've got the right equipment, so we need a ruler, we'll need a pencil for actually drawing the columns and rows of the table, and finally we need a pen to actually write in our values. Once we've done this, we'll see that we need one column for our independent variable, and at least 4 columns for the dependent variable, and you'll see why in a minute. This means typically that your table will have at least 5 columns. Notice that the independent variable goes in the leftmost column, along with its units. The dependent variable takes up the rest of the columns as a heading. It's also given with its units. The reason for the 4 columns is you will do 3 separate trials for each value of the independent variable. In this case, the temperature at say 20 degrees Celsius. Of course, if you do more trials, you will need to add extra columns to account for those extra trials. The final column is for an average. As well as this, the table also needs a title. And the title should be sufficiently descriptive and should include the independent and dependent variables. Once you've got your table, you can record your results for each trial, and that just leaves you to calculate averages. An average is simply the middle of all the results that you've obtained in similar trials. For example, all the results that you've got at 20 degrees C. We calculate the averages using the following sum. What we do is we take the results for identical trials and add them together, and then divide them by the number of trials that are carried out. And in our case, in this example, that's 3. Now it's easy to work these out on a calculator or a scientific calculator, but sometimes students trust their calculator too much. Look at the following calculations. In this first example, we add all of the numbers together, but the calculator doesn't give us the average. What actually happens in this example is the division is done first, and that's due to the order of operations, or BIMDAS, and so the answer comes out as 11. In the second example, we actually do the addition first and then use the division as a second operation to ensure that we get the correct number and the average. Once you've calculated them, add all your averages to the table. To summarise, whenever you draw a results table, it must have the following: a title which informs the reader what's in the table, your independent variable and dependent variables in the headings of the table, the units for these headings, and your calculated averages.